Hello learners, in continuation with scheduling procedures, now we will take an example on scheduling the maintenance jobs by sequencing technique. For example, 3.1, in a repair shop there are 5 orders P, Q, R, S, T to repair and due dates are as follows. For example, jobs P, Q, R, S, T and the repair timings are given in days. 10 days for P, Q 8 days, 5 days, 11 days and 6 days. Similarly, due dates are also given. So, in the table it is, you can see that due dates and repair time in days it has given. So, prepare a sequence of repairing the above jobs under the following rules. There are various rules: shortest processing time, first come first serve, latest processing time, end due date, treating job Q is to be done on top priority and others in last in first out. Handling the maintenance jobs by sequencing. For the above set of jobs, calculate total completion time, average completion time, average number of jobs in the system and average job lateness. Solution. First we will find out by shortest processing time rule. So, as per this rule, the job with shortest time is scheduled first, immediately followed in next lowest repair time and so on. In each calculation, compute the flow times for the jobs, that is the amount of time the job spends in the system to get completed. Flow time for a job is the addition of waiting time and the repair time for the job. Job lateness is the positive difference, if any, between its flow time and its due date. Now you can find out job sequencing because it is on the shortest processing time. We are not keeping it as a QR, PQRST. Here R is having 5, that is the minimum 5 days to repair time. So that's why shortest processing time machine will be repaired first. So, in that sequence we have arranged R, T, Q, P, S and then the repair times are given. Then flow time for means how much time it takes. So, that is flow time, it is given. Then due dates are already given. So, then job lateness, how to find out the job lateness. Job lateness is a difference between the positive difference between flow time and due date. So, if there is a negative difference, we can show it as a 0. So, like that in R there is a difference, means it starts at means it takes 5 days to repair. So, but the due date is 35 days. So, there is no problem, within 5 days we can complete it one machine and given it for the production purpose. So, there is no any job lateness. Similarly, for the second job also, T also there is no any job lateness and Q also there is no any job lateness, but for P the job lateness is how you are finding the job lateness? It is the difference between the time taken or flow time minus due date. So, that is here 29 minus 18, that is equal to 11 for the P job. So, similarly for S job it is 40 minus 15, it is giving 25 days. So, total job delays or job lateness, that is equal to 36 hours. Now, we have to find out total completion time. So, for completing all the jobs it is taking 40 days. Then average completion time is equal to total flow time by number of jobs, that is equal to total flow time is 110, cumulative time, that is divided by 5. So, the number of, how many number of jobs are there? Here we are having 5 numbers P, Q, R, S, T. So, 5, that is equal to 22 days. The average completion time is 22 days and then average number of jobs in the system is equal to total flow time and total divided by total repair time, that is equal to 110 by 40, that is equal to 2.7 jobs, means around 3 jobs are in the line, in the pipeline. So, this is the average number of jobs in the system or in the maintenance undergone these are all going on maintenance. So that is around 3 jobs are under the maintenance. Then these results could be calculated in other way also, that is it is given first 5 days 5 jobs in the sequence, in the next 6 days 4 jobs are in the sequence, like that we have to arrange. So then we have to find out total repair time, that is 40, average number of jobs in the system, that is equal to 104 by 40, that is equal to 2.6 jobs in the system, and the average job lateness is equal to total number of job lateness by the number of jobs, that is 36 by 5, that is equal to 7.2 days is the average job lateness. And then our first in first serve rule, it is also shown here. So it is first in means PQRST only, first in first out. So accordingly we have to calculate the what is the flow time and find out the difference, the job lateness. Here the job lateness is around 29, but in the SPT rule the job lateness is 36 days. So that is the difference. So we have to calculate for each rule, LPT rule also we have to calculate, and then summary. So for calculate all the in all rules, SPT rule, first come serve rule, LPT rule, EDD rule, and NPE UFO rule. So in all these you can see that the SPT rule takes completion time, it is only 20.8 days. So that is the shortest processing time. So that is the it is efficient method. Here we have calculated, we cannot compare, but it is depends upon. So here just for showing the shortest processing time means here in 20.8 days all the processes, all the machines will be repaired. So we cannot make any generalized comparison statement on the basis of only one example. However, it appears that SPT is efficient in average job completion time and in reducing the average number of jobs waiting. It increases the average job lateness as some long process time jobs may be pushed behind in queue. First come first serve rule seems to function fairly well on all counts. So scheduling n jobs and n machines using Johnson's rule. So here Johnson's gave the following algorithm for finding sequence of a situation where there is a group of n jobs to be processed through 2 successive work centers. The rule ensures minimum completion time for the group of n jobs by minimizing the total idle time of the work center. So the rule sequencing algorithm is identify the job with lowest processing time among all the jobs on both the machines. If this shortest processing time belongs to the first machine or work center, then this job is placed first in sequence. If the shortest processing time appears under the second work center, this job is put last in the sequence. So having placed the job, now delete it from any further consideration. For the remaining jobs, repeat step 2 until all the jobs are placed in the sequence. Following example illustrate Johnson's rule. Example 3.2, an automobile work has 6 cars for repair. The repair consists of 2-step procedure, that is dent removing and painting. The time estimates are as follows. Car numbers 1, 2, 3, 4, 5, 6 and time estimate for dent removing and time estimate for paint removing are given. So now find the correct sequence of operation and spares. Prepare a Gantt chart and schedule chart so as to minimize the idle time. Solution sequencing. Step 1, the most minimum time among all the jobs, all 12 jobs, which one is the minimum, that we have to identify. 6 denting jobs and 6 painting jobs is taken by car numbers, that is 5, say C5 for denting, that is 8 hours. This is the minimum one. So as the least time 8 for C5 car 5 falls under first operation, this is to be sequenced at the extreme left. So we have to prepare. So extreme left means it has to be repaired first. Now this C5 is deleted from further sequencing. Step 2 is to be repeated till the sequencing is completed. As the next shortest processing time, that is 9 for C2, belongs to the second work center, that is painting. This is to be sequenced to the extreme right, because if it is first work center, then it should be given at the left side, and if it is second work center, then it has to be given at the right end. So like that we have to arrange sequence. So the next minimum is 10 for again C2, so which is already sequenced and deleted from the further consideration. Then next minimum is 11, which appears in C3 for work center 1 as well as in C4 for work center 2. Therefore C3 goes to left and C4 goes to right. So that you are seeing in the table, then C5, C3, then C4, C2 are there, and another 2 machines has to be allotted. So similarly, the next shortest processing times are 12 for C5 for work center 2 and 13 for C4 for work center 1. But these are already allocated, thus C6 occupies next position towards right side of the left out position, as this has got the next least process time, that is 14 hours at work center 2. Then obviously C1 comes in the left out position, thus the sequence is like this, like C5, C3, C1, then C6, C4 and C3. So the sequence is given. So then if there is same minimum processing time for 2 jobs, one at work center 1 and other at work center 2, then the one with the shortest time at work center 1 is kept at the most left and the other at the most right. So if there is a tie in the shortest processing time for any 2 jobs in first work center, then the sequence is to be determined by checking their minimum time at the second work center. The job having minimum time is to be allocated most right and the other is kept just before it. So if the tie for 2 jobs at second work center, check their minimum time at first work center, and the job having minimum time is to be given left position and the other just after it. If there is a tie in the processing times of 2 jobs with both the machines or work centers, then sequencing is done by selecting arbitrarily. In this case, the problem will lead to multiple optimal solutions, more than one optimal solution. So this is the scheduling chart one has to prepare. So this is already given in the unit. You can see that the C1 it is given. So scheduling chart preparation is very easy. So like this one has to arrange all the schedules. Learners, after listening this video lecture, you will be able to solve the different problems on scheduling and sequencing techniques in SPT, first in first out and EDD, etc. Thank you.